everyone, welcome back to my YouTube channel. Okay, so today we have a new project, a project for a project, if that makes sense. So if you've been following my channel, you've probably seen me designing and creating a new model for my girlfriend, the third model. So the big heart structure, you may have seen this before. If you're new to the channel, you probably haven't seen it. So this little structure is a stainless steel heart frame for the model, as I say, so it will rest on a platform. So basically what I've done is I have created all these rings, 30mm rings. I have created 4 of these 3.2mm sort of heart shaped stainless bars. Also for the outer surround, the main part of the structure heart is 5mm, so also 4 pieces. So what I need to do now is I need to start assembling this, but the problem is I have a welder, but the welder that I have is a TIG welder and I don't want to use a TIG welder to do this. So what I want to do is I want to create like a resistance welding machine. I have one, I have 2 of them actually. I've made one and then I have another one, but they're no good for this. So what I need to do is I need to make a miniature spot welder to weld, to get into these, what do you see, 30mm holes of the ring, the center. So what do I get this template over here? So what I need to do is I need to create 4 welds to each ring. I could use a TIG welder. I could turn the TIG welder down very low to do this, but I don't want to see the welds at all. So I basically want the 2 round parts off each bar in each ring to just have a wee minute weld on them, created from this machine that I'm looking to build. So what I'm going to do now is I'm going to move into the shade and I'm going to start drawing it up on paper, and then we're going to make it somehow, and hopefully it works in the end up, and if it doesn't I will revert back to the TIG welder. So I hope you enjoy. Okay, so before I start putting anything down on paper, I have to give a wee discussion here what I'm trying to do. So we have 40 rings, we have a main bar this side and we have a main bar this side. And then we'll have another bar over the top of each of the rings at one side, obviously. So there's a lot of work on this, as you'd expect. So what I need to do here now is I need to create a spot welding machine that's capable of sliding in and out of each one of these little slots or gaps, which is approximately 12mm by 22mm. So I'm not going to talk about this project again. I'm going to just set it aside now for the next video to come, which will more likely be part 2 of this Model 3 for my girlfriend. So so what we're going to do now is we're going to start designing it, the welder down on paper, just giving a wee sketch of what we need, and hopefully it all goes okay. So yeah, let's go. Okay, so the next step here now is giving a little sketch on exactly where we want the welds to be, and how I'm going to go about it, and how I'm going to go about placing the electrodes into the points of interest, or the points that need to be welded. So we're going to move this template out of the way completely. The next time you will see that, apart from the little corner piece here you can see, will be on part 2 of a video that will follow on my channel. So part 2 of that project. So what I'm going to do here now is I'm going to do a little sketch so say, when I bring it back in, sorry. So say this frame, the structural frame was finished completely, say in 2 weeks time, and I run a hacksaw through the 4 bars, and then I turn the face round, looking down on it, on the face itself. So you'll see 4 bars, you'll see 2 big bars, the 5mm bars, and you will see a ring, if you cut it in the right place and not on top of the ring. So what I'm going to do now is I'm going to move this out of the way. We're going to do a little sketch here to show exactly what I'm looking to do here, or what I'm looking to achieve. So this drawing's not to scale. we are going to draw a big circle here. So this here is basically one of these rings, 30 millimeters, not to scale of course, just for this little sketch, this discussion. So this is the outside of the ring, and this is now, let me see, the inside of the ring. So this is the center of the ring itself. Okay, so next step now is drawing the two bars. So you basically imagine looking down on the face of that model, that structural frame. So if I look down on this, we'll see two 5mm bars at either side. Then this is the back face and this is the front face. You will see 3.2mm bar, two of them, here and here. So what I want to do is I want to create a mechanism or a system that's capable of welding at this point and this point, off the bar and off the ring. So I need something that comes in here and welds at that point. And I also need something that's capable of well, contacting the stainless bar at this point, creating pressure here, and creating a wee small weld pool. It's not a structural weld as such, it doesn't need to be totally strong, it's only for model making. So yeah, so we have the maximum distance that we need to weld here is, well, we need the current to go through is 5mm plus 2.4, which is 7.4 millimeters. So yeah, so we don't need a completely through weld like this. What do I draw it out here? We don't need at the gap because we don't want the weld, we don't want to squeeze deform the circle in the center ring either. So we need the squeeze force to be not excessive but just enough. We also, so say if you can imagine, so these two radiuses meet. That's where we need the weld on each of the ring. The ring will be held in 4 places. So there you go. So the weld doesn't need to be completely strong. So what we'll be doing here is we'll be molding the metal on the stainless bar and the stainless ring. So hopefully I've made that clear there. So there'll be 4 points, 1, 2, 3 and 4. We just want the slightest weld. So if I was to come on here with a TIG welder, TIG torch here at this point, and place a weld here, you'd see that weld. I don't want that weld there. It also makes it very hard to clean and they end up. So hopefully with the spot welder we will still see the nice stainless finish, and there won't be any tarnishing or burnished stainless. So we're going to move on here now and start drawing the power source leading to the mechanism. Yeah, so hopefully you enjoy, and hopefully I've explained that well. So yeah, moving on. Okay, so moving on now to the system itself. So my initial or my preliminary plans, my ideas is to use a microwave transformer to do this. So what I'm looking for is something that's low voltage, high current, but to do this I have to modify the microwave transformer. I have already done this in my previous videos, well, one of them, and then I made my own transformer from my spot welder. But I will put the link in the description. So the video that I used the modified transformer on was the resin rubber cutter for my smart glove. So if you haven't seen that, do watch it. It's really detailed and interesting. So what I'm going to do here now is I'm going to sketch out this little system that I'm looking to build for this welding process. So drawing out the transformer here first. So we'll have a transformer, the microwave. So we'll have the stacked laminated strips, looking like so. We'll have a primary window, and we'll have a secondary window. So the primary window will be full of copper wound wire. We will not touch it, so we need to be careful we don't damage that. Then we'll have 2 terminals that exist already coming off for power. So this will be 230 volts AC power. So this is where the modification begins. So on this transformer I will modify the windings. So there's probably, I don't know, thousands of turns in there, I'm not sure, but there's quite a few. As the voltage is stepped up there for the transformer, for the magnetron. So what I'm going to do is I'm going to reduce it down to 1 turn with 25mm squared cable. So what I mean by 1 turn is I will go in, so I'll get 1 cable and I'll come into it. The secondary winding area with the window. So we'll go in and then we'll come back through and we'll be like this, 1 turn, and then we'll come back out again. So this is the power, the output or the input to my mechanism that I'm going to create. So this is 25mm square. So it's very important that this is a low voltage but high current. So to do that is limit the number of turns on the secondary winding. So now we're going to move on to the mechanism. I can't get my words out. So this will be sort of, so remember now that I need to create pressure at this point here. And what I will do is I'll have 1 cable coming in. Not too long because you don't want a voltage drop. So it's important that these cables is of a big size and not too small to keep the voltage drop down, so it's not too no losses. So we're going to come in like this with a terminal. We will have some sort of copper bar that will have a curve on the end of it, and this may be connected to, the 2 bars may be connected to each other, but with an insulator between them to do work, obviously. So if there was no insulator, this machine would be useless. So what I'm going to do then is I'm going to create another bar like so, coming out, and it will also have a curve in it, like so. But it will be cut in a specific way so it can fit in to the heart and to the structural frame. I don't know if I'm going to have them connected yet, but I might use my 2 hands and just work with it that way. Or I might use some sort of sliding mechanism. So we'll have a terminal on this one too, and that will go back to the transformer. So if we bring these 2 together, we'll have the transformer, we'll have the mechanism here, but also we will have coming off this power, and the primary input for the power supply, or sorry, the transformer, we will have a box. I'm just going to draw it as a box, but we're going to have an off delay timer. So what that's going to do is that's going to create, well, I could set a time. So when I hit a foot pedal, so I have a foot pedal like this. When I hit the foot pedal, it will send a signal to the timer, and the timer will set, well, there will be a set time there, such as a half a second, to create current between these 2 points. And then hopefully it will do the work which we need. So the weld. So we're going to move on here now. I'm going to start stripping the microwave transformer. Hopefully I've kept things simple. I think I have. So yeah, moving on. Strip the microwave here now. I'm not going to go into too much detail as I did in the resin rubber cutter machine, but yeah, I'll cover it anyway in the video because it's interesting. So here we go. Okay everyone, so removing the transformer first, here now. So this microwave is just a old microwave that I found in the scrapyard, or the dump. So here we have the primary winding. At this point, so we have to make sure to protect them. Secondary winding not required, so I'm going to cut them out here now just. Okay, so next step now is actually removing the winding. Let me see if I can open it here. All these fine wires in the secondary winding. There's thousands of them, I believe, to up the voltage. So I will demo removing these now, and then we'll start applying the new wire that will be placed in the secondary winding. Yeah, so yeah, all going well. Okay, so we are now ready to cut this out. So it is important here again, I'm going to mention it, not to hit the primary winding. So what I'm going to do is I'm going to place this mask on also to protect my lungs, so it's an air-fed mask, so you might hear it running in the background. So I'm going to cut the secondary winding out here, and then I'm going to drill holes down into the windings themselves to weaken, so it's sort of, it's not like packed in as such no more. So when I put a hole down the centre, the walls will tend to fall away then, and it's not as pressed or as tightly compacted as it was. So we're going to start cutting this now, so I'll put the mask on here. So I just need to be careful here because I'm very close to this bracket. I don't want to hit the bracket, I don't want to cut the bracket, I want to keep it. To support the transformer if I build an enclosure for this welder. So yeah, I'll keep on going here, so I just have to keep eating away at it with a grinding disc or cutting disc. Okay, so I can start drilling the holes here now down into the secondary winding to weaken it, so it's not as compacted in, and then we can tap the secondary windings out. Hopefully it goes well here. Okay, so next step now is boring these holes, or drilling them. So I'm going to drill 2 holes in each one of these copper, blocks of copper, shall I say. So there's thousands of wires here. They're all squished in. Yeah, so we're going to bore 2 holes here now and weaken it. And then we can move on to placing a new run of cable around the secondary winding. To create 1 turn only. Low voltage, high current. So we're going to start boring this now, drilling these holes. 2 in each one of them. Each copper block, shall I say. What it looks like here now. So 1 hole at this end and 1 hole here, and then we can keep making the drill bit bigger if need be. We could start pushing the copper winding out from the other end. So it's like a C shape now, it used to be like a 0. So yeah, let's go. They go smaller first. No, that's not good. So try not to slip off to the laminates here. You have to keep in the centre at all times. Job, that's not good either. Better. So you can see it's time consuming, very footery. So now we can try tapping this out just. So you can see there, sorry I have the mask on here, you can see there that the windings is starting to pop through the lower end. So we'll keep battering it out here and reaming it out with a drill bit. So basically what I'm doing here is bit by bit I'm tapping it out and drilling, reaming round the area, the window of the winding, the two holes in the secondary winding. So yeah, you have to just keep working with it to get it out, but it's nearly out here now, so try not to destroy the insulator or the barrier between the secondary winding and the actual laminate plates themselves. So there we go, nearly out the back here now, look. So basically I might be able to pull it out now. Just about. There we go. So there's the old secondary winding out. So next thing now is removing this wee small set of winding here too. So I'm just going to demo removing these little wraps for on the secondary winding. Okay, so that's it, finished. Next step now is placing the secondary winding in there. Okay, so we're ready now to wind the secondary winding. But first things first, I have to connect the primary winding back up to this terminal. If you have seen there in the video clip, I removed the thermal fuse that lay in between the primary windings. Reason being is I don't want it to be there. Any of the transformers that I've used in the past never had one, so I don't want it there. Yeah, so what I'm going to do is I'm going to place a wee branch on here, 15 amp wire. I'm going to start the soldering up here, gas soldering. If we get her going now. So the primary winding should measure approximately, let me see if I go from this terminal to this wire, about 2 ohms. So I need that 2 ohms to be back on this connection, but at the minute you can see there's nothing, so that's not hard to fix. So we'll repair this now and then we'll move on to the secondary winding. But placing the 25mm squared cable into the window area. So here we go. So we'll start by placing it on the winding itself. We'll just trim this to size first because I don't have any side cutters on me. So I want it sitting approximately there. Tricky. Okay, so that's one side on. So the soldering end's running out of gas. Hopefully there's enough on it to do it. Okay, so that's good. I'll zoom in there just to show that. See if I can get it into view here. Oh. Wrong way. There we go, so that's a connection made again. So next step now is, well, going back to the secondary winding. Hopefully things start getting interesting now. Okay, so how silly of me, I forgot to do a little test here on the primary winding. So with the multimeter set an ohm setting across the two terminals, we are now getting a reading. It is reading 2.5 ohms. So that's well within spec now. It's not an open circuit, it's not a short circuit. So moving on. Okay, so transformer nearly finished. Next thing we need to do is wind the secondary winding. This is the cable we have sourced for it. So I'm going to do a little discussion here on what I have sourced for it here just before I move on. So this is a foot pedal, foot switch. So this will engage the transformer, the welding process. This is the 25mm squared cable with terminals and all connected. So this will be placed into the microwave transformer in a wee minute. We have these two buzz bars sourced. I have them tapped and all here and ready to rock. So basically these will be strapped to this. So these buzz bars is 15mm wide with 3mm thickness. So that's equivalent to 45mm squared cable. So they should be capable of handling high current for half a second or so. Just as the cable will be. So the cable is 25mm squared. So also we have this little module here. So this little module is an off delay, on delay timer. It can be switched with these little tabs or these little jumpers between the different seconds, milliseconds, and between off delay, on delay. So there's also a wee branch there if you want the input power to be at the common side of the relay, which I don't want. So this is going to be the high voltage side here at the relay. This relay will control this transformer, the primary winding. Sorry, I dropped that there just. So we have the input to this delay timer. So that's what the power supply is for. So this power supply will be connected to the input of this timer, and the timer then will be switched with this foot pedal. So this will be in series with the power supply and the little module. So this is a push to contact, obviously. So this is normally open at the minute. So we're going to do that now. We're going to wire this all together. We're going to start with the transformer. Then we're going to do the control side of it. This here, the actual electrodes themselves, these still need modified. But for the meantime, I'm going to just put everything together. And then if we need to make some sort of sliding device, so these clamp the rings. Well, the way I want to do it. Let's see if I can get a ring here just. So, okay, I've got one here now. So I've got a wee sample. So I will then follow on when this electrical side's all done and the transformer's done with how we're going to make well, the little curves in this flat bar, or how I'm going to insulate these two from each other, and how if I'm going to make some sort of a sliding device. So we're going to move on here now, and we're going to start wiring this all up and doing the transformer first. So here we go. Okay, so I keep saying wind the transformer and secondary winding. When I say I'm not actually winding 1,000 windings here, I'm just placing one cable into the secondary winding area. Okay, so I am now ready to place this 25mm squared cable in through the window area of the transformer. So around the core once, around the core of the transformer once, and yeah, hopefully it all goes well. So here we go. So we want the tails coming out the opposite direction from the opposite end from the terminals of the primary winding. So we're going to start this way, placing this 25mm squared cable in through. So one turn. Hopefully this works out because the terminals is already on the end of the cable. So you want the tails nice and equal also. We can adjust this if need be once it's wound. So I might need a bit of WD-40 for this. Bit of fair liquid. No, it should be okay. It's working out grand there. So keeping it slack at the start is important. Then you can tighten it up at the end up. So pushing this down. Oh, she's tight. There we go. I wasn't joking about the WD-40. There, I'm going to get a wee bit here. Just a wee titty bit. Helps. So what we want now, we want the two tails equal to the side. So we can keep tightening it up now. So we're getting there. You can see here now. Okay, not bad. A wee adjustment needed, but I'll do that now just. Okay, so I need more to send. So push this one back, push that one back. Oh, it's tricky. Tricky to get it perfect. I think that's near enough. So moving on to the control side. Okay, so we're going to start putting something together here now. So at the end of the two tails, the secondary winding, I'm going to place this buzz bar that I talked about onto each one of the little connections that I have placed on here. The eyelets. So using 5mm cap bolts. There we go. So that's one. And that is two nearly. There we go. So I'm going to follow on with this mechanism once I get all the control side, all the circuitry done for the transformer, the power supply, the low voltage stuff, the foot pedal. When I get that working, I will then come up with some sort of plan to like a sliding mechanism with an insulator so the two of them can't touch, obviously. As I've mentioned, if the two of them's touching, or if I make a bracket here for these two, using a metal material such as steel or even aluminium, or copper, no good. Will not do its job then, so it needs to be an insulator. So I might use nylon or something, or some sort of high temperature fiberglass. So we're going to move on here now to the control side, and yeah. So we're going to start with we'll start with the foot pedal. So when I bring it into view here. So this power supply needs to be wired into series with the foot pedal. So we'll do that now. And the camera's rolling. So this is only temporary. Let's see if it works. Next thing now is so this, when I make contact in this foot switch, I get a signal back from the power supply, which is basically ground, back to the power supply. Oh, sorry, back to this device, this timer. So here at the red wire will be 12 volts sitting here all the time, constant. And then when I hit the foot switch, I get the signal ground, which powers the delayed relay. So into these two connections, VCC and ground. So this is low voltage, 12 volts. Okay, so that's the low voltage side done. Next step is doing the high voltage side for the transformer primary winding. So I'm going to bring that into view just. So here's the transformer, foot pedal, and the little delayed timer. So I'm going to turn this on here now, the power supply just. Okay, so when I push the foot pedal, you should see a green light up here. Well, first, you can see a green light in the power supply here. So when I hit the foot switch, I will make contact between this black and white wire. So here we go, there we go. So see the green light going out again. Let me see if I can bring this into view. the green light going out is the second set, or the millisecond set. And I can use this little potentiometer here to increase it or to decrease it. So that's weld time. If I want seconds or if I want minutes, I just alter these little jumpers. But I don't. I want milliseconds. I don't think I would go near seconds. I think there'd be enough power there to do enough current to do what I needed to do over say half a second. So at the minute there, it's probably over 1 second. So I'll screw down. I probably want half a second. I'll down more. There we go. So hopefully you can see that. So what I need to do now is run the primary windings to this module, this little relay. This relay can handle 10 amps. I think that's probably max or what this here pulls. I don't know if it'll pull. I don't think it would pull 10 amps. As far as I mind, I could do a wee test on it, but for the meantime, I'm not going to. I'm just going to do this. Keep on with this demonstration. Okay, so we're going to do the high voltage side here now. So just to confirm that the wee module's working, I'm going to the normally open side of it. So common and normally open. Listen to the multimeter, you'll hear a wee beep. So that's the weld time, that beep, when I connect this transformer to it. So listen again. One more time. Okay, so we're going to move on to wiring this transformer up now. And hopefully it all goes well. So this is plugged out obviously, so I'm going to place little spade connectors on this now. So we're going to place the transformer, well, wire it straight to this, but it will be, the mains will be connected to it. So I'll be placing live to one end of the primary winding, and basically what I'll be doing is I'll be putting this module in the circuit to control it as a switch. Okay, so here we go. Also, not to forget the earth. So we're going to put a little eye in this, a little eyelid, and screw it to the transformer just in case it's live or becomes live. So plugging this live wire into the transformer needs a wee squeeze. We'll screw this earth onto the bottom. And next step then we'll put the neutral to the module. So we'll move the foot pedal for the meantime. Okay, so final thing we need to do here is we need a wee wire going from the one-off terminal on the primary winding back to the common of the relay. So I need to get stuff on here. Okay, so I got another piece of 2.5mm neutral wire. So here we go. Tighten the terminal a bit. There we go. So back to the little module now. Okay, so that's it completely wired. We will do a wee test now. And yeah, so we just need to plug the mains in at the floor here. So that's it plugged in. We'll check the voltage here just before we fire up. So from here to this side, there's 240 volts on the meter there. See if I bring it up. There we go. So that means now, once I make contact with this foot pedal, at this point, we will get voltage here. So if I get this jammed in some way. Okay, so I'm at the wrong end. So we're getting, let me see, 0 volts. So once I make contact here now, I'll get to, have to make sure the secondary winding here is not touching. So we'll keep one of these up near the meter. Okay, so the minute it's reading 0.1 volt. So if I hit this, there we get 240 and it cuts out again. Sorry, my arm might have been in the way there, we see. So if I hit the switch on the foot pedal here, we should get 240 volts at the meter, at the primary winding, only for a half a second. So here we go. There we go. So you've seen the meter jump up there. So next thing now is to measure the voltage on the secondary winding. So what do we see to move this back a bit here? So I'll keep the switch where it is. I'll bring the two electrodes into position. So I want to make sure this voltage here is low. It's obviously going to be AC. There's no rectifier in this circuit at all. So what do you see if I bring the meter back a bit? Or sorry, the camera. Hopefully you can see that now nice and clear, the setup. So yeah, we'll do this now. We'll do a wee test here. So there we go. So we have the multimeter connected up to the two electrodes. When I push the foot pedal, we will get a voltage here. It won't be a steady voltage because the delay timer is well, it's only letting the transformer come on for half a second. So what I might do here is I might deliberately just cross it for the meantime to see the voltage on the secondary winding. So let me do this here. So I'm going to get one of these wires, make a bridge. So I'll plug it out here 2 seconds. And we will take the neutral wire out of the module and we will place it directly. We'll put it into the normally closed connection of this little module, so that'll help close the circuit. Well, it will close the circuit. It won't help. So what I jam this in. So this is only to do the test. So what do we see if it works now? If I switch this on again. So you can see the voltage here in the multimeter. So the voltage on the secondary winding is 0.5. Couldn't be that low. Okay, so there we go. The lead fell off. So 1.58 volts, which is good. So all working. Oh, what a rush! How to get that done? Right. So what we're going to do now is we're going to set this back where it's meant to be on the normally open circuit. So the mains is disconnected. So there we go. Back in the circuit, in the circuit it should be in. So again, we're going to switch it on. So we have the high voltage side done. When I bring the multimeter back into view here, you see, let me get these leads from falling off. So if I push the foot switch now, you can see a wee voltage appearing in the multimeter, but it won't be for very long. That's why I close the circuit there just to show you. So here we go. There, so it doesn't even get up to 1.5 volts because it's for a short burst. So that time might need increased. I'll increase it here a wee bit more. With the module using a potentiometer and a wee screwdriver. So again, so there, it's on for about a second now. So next step now, I'm going to do a wee test here. I probably shouldn't, but I'm going to do it anyway. I'm going to put a bit of wire between here and you'll see it glowing. So let me get a bit here. Okay, so the wire's in position. If I hit this, you might see the PVC on this little brown wire heating up. Or you might see nothing if it doesn't work. So here we go. There you see the smoke coming off it. If I go again, oh, there we go. There's the smoke. So I'll need to watch the tablecloth. There we go. I'll hit her again. You can see there now, it's clearly working. So you see it glowing red underneath. One more time. So I'll stop at that. Oh, I'm choked. Okay, so we can see it clearly works. Brilliant. The afterlay is working too. Perfect. Sorry, I have the jumper or my t-shirt over my mouth here, my nose. Afterlay working perfect. Transformer working perfect. Not heating up for them little short burst. So the next stage now is making the mechanism that will these two sliding buzz bars can run against, and then we can start shaping them to match the rings for the model. We might put this in the enclosure to end up, or we might not. We'll see. We'll see how well it works or performs first. So I hope you enjoyed. We're going to move on here now to the mechanism. Yeah? Yeah, so all good. Okay, so I'm going to try and do a wee demo test here of it. I know it's not, there's no clamping device yet, but it's just to give an idea of how it will weld. So we have the bits sitting in there. We have the 3.2mm bar and the 2.4mm ring. So we want to do, I'm going to push the foot pedal here now. If it's lined up, I think it's okay for this test. So I'm going to put a wee bit of pressure on it here. So away we go, a wee weld. So I've screwed the timer up to approximately 1 second. So here we go. I'm going to hit it once more, just to make sure it's welded. So you can see there, when you see, the ring has welded, nice and neat. So I'm going to take the camera off the stand just. Okay, take it out to the daylight here. So the ring is welded as we want it. Don't know how strong it is. I'm going to break it off now in a minute. Doesn't need to be that strong anyway, as I mentioned in the earlier video clips there. It's only for art and design, craft. So what do we see here? Quite strong, you know. I'm pushing it. But that's all we need. So we need 4 wee spots like that on each ring. So the next step now is to make the little mechanism that will hold the rings during clamp time and the bar. So basically some sort of C-shaped curved copper electrode, and also, well, 2 of them, and one of them will be sliding against the other. So these leads, the longer they are, the more losses there is. So we want to keep them as short as possible. So I think they're okay at the minute. We might shorten them to create more power here at the rings, but we'll see. So we're going to make the mechanism here now, and hopefully it all goes well. Okay, so we have a little issue with this little one transformer setup. So I'm just going to demo that before we go on any further. So, I previously mentioned I don't need the weld to be that strong, but I want it to be stronger than what this is achieving. So, what do we see here if I do demo this? Just for future projects and stuff too, it'll be much better. So what do you see if I can weld this? Okay, so I got a wee bit of pressure on it, but not too much. So, that's welded clearly. It's probably okay for this project, for this model, for a 3.2mm bar. But what happens when I'm going to do the 5mm bar? It'll be much weaker welds. So if I touch this, it's welded, but it's not welded, it's not very strong. So I have come up with another plan to increase the current here. I can't increase the current anymore on this transformer because I'm at 1 turn. Half a turn's no good, it doesn't work because the voltage is too low. So what I'm going to do here now is I'm going to get another transformer. I have to get another microwave from somewhere. Very hard to get now because nobody wants to give them out. Scrapyards or nothing, or council. So I'm going to get another transformer. I'm going to do a wee diagram here and explain exactly what I'm going to do. But hopefully it works. So when I get a piece of paper here just. Okay, so ready to do this here now. So we have 1 transformer currently. Primary winding. Live, neutral, in. And we have 1 turn on the secondary. So yeah, so what I'm going to do here now is I'm going to add another transformer. So another primary winding. These primary windings will be in parallel. And the live live out then. So live in, and then neutral in. Okay, so on the secondary winding then we'll have another turn. And we will have these two secondary windings in series. So the voltage induced from this primary winding to the core and then to this secondary winding will be added to the voltage induced in from this primary winding to this core to this secondary winding. So the two of them is added together. So say like there's 800 amps sitting here, and here my current then at these 2 points, weld current on the device will be hopefully double the power. So what I'm going to do here now is I'm going to strip another microwave. Well, I'm going to go and get one, strip it, and then I'm not going to do a video on stripping the transformer since I've already done one. But I'm going to take pictures and yeah, take it from there. So hopefully this works, and hopefully this becomes a better welding machine for, well, when I'm doing the 5mm bar to the 2.4mm rings. So let's say that this doesn't work when I wire it together. This will probably because the polarity is mixed up here on the secondary winding. So this just needs to be switched by removing the neutral and live wire and just flipping it over the body. So the voltage and the currents go in the right direction at the secondary windings. So yeah, I'm going to do this now and take it from there, so I hope you enjoy. Okay, so I have got another microwave, and as you can see I've got a lovely big, beautiful, clean transformer. Like the ones that I know I'm very familiar with. So what do you see? So I have one here already. This one is identical to that one, just a different nameplate on it. The reason I'm not using that one is because it's been lying about too long and the rust has got to it, the laminate plates. So what I'm going to do here is I'm going to use this one now, put it in series with this one, and then I'm going to, maybe in another week's time when I get another microwave, I might switch this one to this heavier looking transformer, the more common type, as I call it. So yeah, this one has a thermal fuse too, so I'm just going to get rid of it. I don't want it. So that's for protection on the secondary winding. It's this high voltage winding here. So what I'm going to do here now is I'm going to remove this high voltage winding, just like I done to this one. But yeah, I'm not going to do a video of it. So then I'm going to go back and do the wiring process of this, and hopefully we increase the current. Okay, so as you can now see, I have 3 transformers. I have 2 that look very similar. Then I have the other one that looks, well, this is the first one that I used for this project. That you see me removing their windings. So I'm not using this one now. I'm going to use this new one and this one that's robbed from my existing project that came on my YouTube channel. So this was for the rubber resin cutter. In the meantime, I'm going to borrow it just to, well, I might just keep it for this project and get another one for the rubber resin cutter. So, okay, so now I'm going to do, I'm going to remove this one completely. So I'm going to wire up the primary winding of this one. Then we're going to connect this one in parallel. But before we do that, I'm going to do a test and determine the current on the output of a secondary winding using a clamp meter. So I put the camera on the stand here for the next, well, a couple of minutes to do this first. Okay, so we have the multimeter on the primary winding of this transformer. This one's not wired up yet, so I'm just going to demonstrate the current on the primary winding just to see if this little device can handle the current, because the relay is rated to 10 amp. So I'm looking to see if the current from the input current of this and the input current of this added together doesn't exceed the 10 amp limit. So what I'm going to do now is I'm going to do a little just do a little demonstration here of the current from the input side and the output, so the secondary winding. So you'll see the secondary winding current come up in this clamp meter. So here we go. I'll bring the multimeter into view here. So again, the multimeter is set up in the amp settings. Here, at this point, and also the leads. So here we go. Okay, so I'll do that again because I didn't get a look at it there at all. Okay, so that's saying 10 amp when the microwave transformer is completely shorted with this bolt over here. So 10 amps on the primary winding, so that tells me that that relay won't be able to handle two of these. So what I'm going to do is I'm going to put another relay in here, a bigger one, or maybe add an additional one on. So next step now is looking at the secondary winding here. So what do we see? The current, the output, short circuit, was full load even. So here we go. So 1200, it's stating 1200, well nearly 1300. So that's good compared to what that one was here. This one, much higher output for some reason. It must be due with a larger core. Yeah, and if I was to, I'm not going to lift this one because it's live, but if I was to lift this, you can see that these wires is much more heavier on the primary winding than this one. So yeah, to do with the number of windings too, of course. So what I'm going to do now is I'm going to put the two of them into, well, the secondary winding in series. Then we're going to branch the two primary windings, well, connect them in parallel. First things first, I need to get a relay which can handle 20 amps, because obviously that's what it's going to pull now with two of them on full load. When there's copper electrodes here and or a piece of metal with high resistance between it, it might never get to 1200, but I'm just showing it short circuit, full load. So what I'm going to do now is I'm going to move on and we're going to wire these two together. Okay, so I went ahead and wired it there. The traffic got a bit heavy. There was a car passing the house every 30 seconds, so it just didn't bother. So I'm going to discuss it here instead. So we have two primary windings now, wired in parallel through this relay. So this delayed timer, off delay, you can see a wee bridge connection there. That sends a 12 volt supply to this common side of this relay. So then the switching side of the relay goes to this heavy current coil. Sorry, this heavy current relay, the coil side. And then we have a ground, which is black wire, goes back to the power supply, the 12 volts. Then we have the mains coming in to the 40 amp contact. We have then the supply, the switching supply, split between the two transformers. The neutral coming in is just bridged across the glass. So obviously when I measured there was 10 amps, 11 amps, but full load, short circuit. So that will never be the case. Like, as I mentioned, the metal or the stainless being of higher resistance at that welding point. Also, due to the cables that I'll be using, so the cables now that I'm running through this is obviously going to have a higher resistance. So that's going to bring the current down at the end of where the welding points too, keeping that in mind. So the shorter the cables the better. Yeah, so we will check the supply current again using the multimeter. The multimeter, however, is rated to 10 amp. So yeah, we can use a clamp meter anyway for it. So yeah, we're also going to run the clamp meter on the secondary winding now once I wind it in series here. So I'm going to start this now and hopefully it all goes well. It should probably show the control side working here. So when I push the foot pedal now, signal is sent, well, the ground's connected up to this terminal block from the supply. There's 12 volts sitting here all the time from this power supply. When I hit the switch, it sends a zero or ground to this pin up this white wire. Okay, so then it powers this relay as I mentioned there, so I'm just going to show that clicking. So you can hear a much heavier click this time. So that relay is designed for DC current, so it should have no bother with this AC current. So yeah, let's start wiring this now, the secondary windings, and yeah, see how it goes. Okay, so we are ready to rock here now. So what I'm going to do is I'm going to leave the tail ends to the opposite side of the primary winding connections. This is just for good practice for this job. Stay away from the main side. So we'll have a terminal here and we'll have a terminal at the side. So these terminals is for me to connect my mechanism, my clamping mechanism, the miniature one that I am going to create after this video clip. So yeah, for the wireframe welding. So what I'm going to do now is I'm going to start winding this, starting off this transformer, and then we're going to just loop into this one. So here we go. We're not going to tighten it up yet, we're just going to feed it through first. Till we get the right lengths, the tails here equal. I could disconnect the mains to get them out of the way just for the meantime. Okay, we'll keep going. Bit of WD-40. Okay, so the tail might end up being here actually, this side. No, that's right, perfect, same out to both sides. Okay, so that's telling me now I need a bigger tail at this side. Because of a big loop here, look. So I'm going to work with this now off camera maybe, because it would take a bit to get it right. But I'll keep rolling here just to see how it goes. So I'm going to bring this one back. Okay, so that tail's out a good bit there now. Okay, so we're going to tighten this one up now to see what it looks like. Okay, so that's not bad. I'm going to take the camera off a stand. So you can see it's not bad there, so I'm going to work with it here. Get it nice and neat, and then I will connect the primary windings up and do the final test before we create this mechanism. Okay, so I've finally finished winding the transformers, 2 of them. So we now have 2 transformers in series. So the secondary windings is in series and the primary windings is wired up in parallel. So what I'm going to do now is I'm going to do 2 tests. I'm going to do a test using this clamp meter. So this ampage meter. I'm going to detect, read how much current's in the secondary winding. Okay. So short circuit. So I have a branch between this point and this point, creating one loop of the 2 transformers. So I'm going to turn this meter on here now. Set it to 0 first. That'll settle a wee minute here. And then hit 0. Okay, so that's good enough. So what I'm going to do here now is I'm going to again, so what I'm doing is I'm engaging this high current relay, high current contacts within the relay. I'm going to engage this relay, power up the 2 transformers, and measure the current on the secondary winding. So here we go. I'll move the camera into view here too. Hopefully you can see that meter nice and clear. So what I'm going to do is I'm going to hold it on for about 2 seconds till we get a clear reading. So hopefully now it has doubled, or near enough doubled. So the last time we measured the current of 1 transformer, it was approximately 800 amps. So here we go. Okay, so it's reading 1500 amps. So that's good, that's what I wanted. So the next test we do, we are going to try holding the 2 electrodes together again and seeing if there is much of a difference, and see if the welding capabilities has improved. So I will do that now. I'll get set up here and we will then move on to the handheld device itself. Okay, so we are going to try this now. I'm going to put these gloves on just in case. Don't want to get burned here. So, okay, so we're going to place the 5mm bar. No, we're going to start off with 3.2 as the test we were doing earlier. So we're going to place the 3.2mm bar over this one electrode, it being positive or negative. There we're going to grab a ring here. Actually, I'm going to do it without the gloves because it's quite tricky. Okay, so we're going to get this electrode. We're going to push down towards the 3.2mm bar on the ring. So I'm going to place the ring here. This is only temporary to show this test. So, okay, to perform this test. So here we go. We'll do this here now. I'm not keep on blabbering on. So it's quite tricky to set up here. Okay, here we go. Oh, that is a lot of current. It just I wasn't expecting that. So the ring is now completely melted in half. Okay, so what I can do here, the current's great, very large now. So what I'm going to do is I'm going to screw the little timer down to milliseconds. It's currently, I forgot, it's set up at about a second and a bit. So I'll screw it down to milliseconds. I'll screw it down to its lowest point. We will perform another test here. It's a good job I have another ring here, sitting here. So this time hopefully it'll weld it, it won't go straight through it. So what do we do this again? Tricky to set up. Okay, so you can see that time a wee short burst of current. So I'm triggering this device using the foot pedal, as you know. So look at that now for a weld. Perfect. Can't even break it off. And there's no blemish and no tarnishing really to the rod itself. So we're going to move on now, and we're going to, well, I'll do a wee walk around here first before I finish up. So what I'm going to do now is I'm going to create a device, a mechanism that, well, easy set up, so I don't have to sit holding them two copper electrodes all the time. So again, just to finish this video up here, we have power supply, we have an off delay timer, a wee potentiometer here at this point that I was able to screw down here now. So the shorter the time period, the less welding and the less current. Well, same current, but it didn't get to reach its peak, if that makes sense. So then we have this high current contact relay. It's actually a 12 volt relay, but it's got 40 amp contacts, which is required because these under full load is pulling over 10 amps. I believe when the earlier test I done. So we're going to move on now. There's the ring that just melted in half there. We're going to move on now and start with the handheld device. So all going good here. Okay everyone, so I've decided to put a stop or call a stop to this part of the project. The next part that will follow will be, well, following straight into the handheld device, leading from the transformer, the construction of the transformers. So we're going to move on now. I'm going to continue working here. The next video that will follow on this project will be the handheld device. So I have everything ready here, copper electrodes, the high temperature insulating board, all ready to rock. So rather than making this video way too long, I just decided to put a stop to it, or call a stop to this one. So thank you for watching everyone, and I hope you enjoyed. Come again, and don't forget to subscribe and like to my channel. Okay, so final images of the manufacturing stages. So here's the first transformer that I have stripped out, the secondary winding. Here the window area is nice and clear, ready for the new cable to be placed in. So keeping in mind this transformer was not used, I got another microwave and used a transformer that I had. So this is a microwave, the new one, and the core was much bigger. So what I done is I used another microwave transformer that I had in another project with this one. Okay, so the reason behind this change was, well, the bigger the core, the more power, more efficient the welder device will be. So less likely it will be for the transformer to heat up under load. So here I am stripping this transformer out, the new one with the bigger core. So the same process again, a lot of messing about, drilling and banging the windings out. So this is it complete. The next stage then was wiring it up in parallel. The primary windings was in parallel and the secondary windings was in series as demoed in the video clips. So here we have the device complete, ready for the mechanism which I have started. I'm now going to continue on with this and create a part 2 to this video. It will come in approximately, hopefully in the next 3 to 4 weeks, and it should be an interesting piece that will obviously add to this entire system. So thank you for watching everyone again, and do come back. Don't forget to subscribe and like. Thank you, bye bye.